One night, San Francisco went dark. Power out, traffic lights dead, and right there in the middle of chaos, Waymo's robo-taxis shut down completely. Stranded, useless. But Tesla's robo-taxis, they kept driving. No hesitation, no malfunction, just smooth navigation through the blackout like nothing happened. This wasn't a test. This was real. And Tesla has now completed nearly 2,000 unsupervised rides using this exact system across multiple U.S. cities. So what does this blackout actually reveal about who's really winning the robotaxi war? Let's talk about what actually happened that night, because the technical details reveal something far more significant than just one company's robotaxis working while another's didn't. Waymo's entire fleet depends on constant internet connectivity to function. These vehicles need uninterrupted connection to central servers, feeding them real-time map updates, traffic data, and routing instructions. When San Francisco's power grid collapsed, cell towers went down with it. Internet connectivity vanished. And in that moment, every Waymo robotaxi became a very expensive paperweight blocking intersections. The technology that cost millions to develop couldn't handle the one thing every transportation system must eventually face: infrastructure failure. Now here's where this gets technically interesting. Tesla's full self-driving operates on a completely different architecture. Every vehicle runs its AI locally on onboard computers. No internet connection required. The neural network already learned how to drive from billions of real-world miles collected from Tesla's global fleet. It processes visual data through cameras in real time, makes decisions in milliseconds, and navigates based on what it sees right now, not what a remote server tells it should be there. When the lights went out, Tesla's system didn't even register it as an emergency. It simply treated dark intersections like any other driving scenario it had encountered thousands of times before. Elon Musk has repeatedly called Waymo's lidar sensors useless, inefficient, and outdated. That always sounded like typical competitive trash talk, but the blackout accidentally proved something crucial. All those laser sensors that can see in pitch darkness, all those high-definition maps updated to centimeter-level accuracy, meant absolutely nothing when the underlying system architecture couldn't adapt to unexpected conditions. Waymo spent years perfecting technology for ideal circumstances. Tesla spent years preparing for chaos. What makes this comparison even more revealing is the data coming out of California's DMV records. Tesla has now logged over 300,000 autonomous miles in California with 0 recorded collisions, not one accident. Meanwhile, Waymo's safety data looks impressive in their controlled deployment zones, but operates under fundamentally different conditions. Waymo carefully selects areas with detailed mapping, predictable traffic patterns, and optimal weather. Tesla's vehicles operate wherever their owners drive them. Construction zones, rural roads, heavy rain, dense urban traffic, highways at night. The difficulty levels aren't remotely comparable, yet Tesla's collision rate remains 0. Since deploying its safety monitoring system in Austin, Tesla has completed nearly 2,000 unsupervised robotaxi trips across cities most companies wouldn't dare touch yet. Austin, multiple Bay Area locations, including Palo Alto and Fremont, Miami, Tampa, Claremont, Houston, Farmers Branch, even Brooklyn. These aren't carefully choreographed test runs. These are real passengers requesting rides through real traffic with real unpredictability. No safety driver. No human ready to intervene. The progression tells you everything about Tesla's confidence level. Initially, they placed safety supervisors in the passenger seat for city driving and moved them to the driver's seat on highways. Then gradually, systematically, Tesla removed human oversight entirely. And what's remarkable isn't that Tesla did this. It's that they're doing it across multiple cities simultaneously while expanding faster than anyone predicted. In San Francisco Bay Area alone, Tesla's robotaxi fleet grew from 28 vehicles in August to 1,655 today. That's 5,900% growth in 4 months. Waymo spent years gradually building to a few hundred vehicles in carefully selected zones. Tesla just accomplished in 16 weeks what took established competitors half a decade. The expansion list reads like rapid territorial takeover. Las Vegas, Phoenix, including Tempe, Gilbert and Scottsdale, Dallas, Houston, Miami. This isn't testing anymore. This is deployment. What's powering this explosive growth is something Waymo can't replicate: manufacturing integration. Tesla doesn't modify vehicles from other automakers. They control the entire production chain. Every Tesla rolling off the assembly line in Austin, which currently happens roughly every 30 seconds, already contains full self-driving hardware. If regulatory approval arrived tomorrow for fully unsupervised nationwide operation, Tesla could theoretically deploy 50,000 robotaxis within months. Not because they'd need to build them, but because they already exist as personal vehicles that could transition to commercial service with a software update. This is where the Cybercab becomes critically important. They didn't just modify Model Y vehicles for robotaxi service. They designed an entirely new vehicle from the ground up, specifically for autonomous operation, and the engineering choices reveal how seriously they're taking efficiency at scale. No steering wheel, no pedals, no traditional driver controls whatsoever. The interior houses 2 seats optimized for passengers and luggage space. Nothing more. Instead of conventional doors, Tesla engineered butterfly-style doors that lift upward automatically. The frame uses stainless steel construction for durability, since these vehicles will operate continuously, potentially 20 hours per day, every day for years. According to Musk, final assembly takes just 5 seconds. That sounds impossible until you realize what they eliminated: every component related to human driving. The battery pack is deliberately small at only 50 kilowatt hours. This seems counterintuitive until you analyze urban robotaxi operational patterns. These vehicles don't need 300-mile range. They need 200 to 250 miles, rapid charging capability, and constant cycling efficiency. Tesla's ultra-fast charging technology from CATL can fully recharge the battery in 10 to 15 minutes. Some prototype configurations use wireless charging, where the vehicle simply drives over embedded floor pads. No cables, no human intervention. The Robo-taxi autonomously navigates to charging stations, parks itself, charges, and returns to service. Completely automated. Now let's talk about economics, because this is where Tesla's advantage becomes almost insurmountable. Current ride-hailing services charge between $1.50 and $2.50 per mile. Labor costs represent over half of that price. Gasoline taxis spend approximately 12 cents per mile on fuel alone. Tesla's Cybercab operational cost is estimated at 18 cents per mile total, with energy costs between 3 to 5 cents per mile. Eliminate driver salary, reduce fuel costs by 60 to 75%, lower maintenance through simpler electric architecture, and suddenly charging $200 monthly for unlimited urban rides isn't just possible, it's profitable. Traditional taxi companies can't compete with those economics. Mass production is targeted for April 2026, and Tesla is already completing critical regulatory groundwork. They've officially registered these vehicles in California as autonomous vehicles. Internal sources confirm the strategy: deploy Model Y vehicles first to gather real-world operational data, then apply every lesson learned to optimize Cybercab production. Tesla is currently hiring factory workers specifically as AI operators to manage fleet logistics and navigate regulatory requirements. What separates Tesla's approach from Waymo's at the most fundamental level is how they think about the autonomous driving problem. Waymo focuses on perfecting the technology in carefully controlled major cities with exhaustively mapped environments. Their fleet uses vehicles from multiple automakers, each customized with sensor suites costing tens of thousands of dollars. They're trying to achieve near-perfect reliability in specific zones before expanding. Tesla took the opposite philosophy. They're training their AI on imperfect conditions from the start. Every Tesla owner who enables full self-driving contributes data to the neural network. The system learns from billions of miles across every possible scenario: snow, heavy rain, fog, construction zones, emergency vehicles, pedestrians behaving unpredictably, cyclists, debris, animals crossing roads. Everything that happens on real roads feeds into the training model. The AI doesn't learn perfect driving, it learns adaptive driving. This philosophical difference explains the Blackout result perfectly. Waymo's system optimized for ideal conditions failed when conditions became non-ideal. Tesla's system, trained on chaos, treated the blackout as just another scenario requiring adaptation. Tesla has also announced plans allowing private owners to add their vehicles to the Cybercab network when not in use. Tesla retains 30% of revenue while owners receive 70%. Within a year, this program could launch. The implications are staggering. Millions of existing Tesla owners suddenly have passive income opportunities. The robo-taxi fleet doesn't just grow through manufacturing. It multiplies exponentially through crowdsourced availability. The critical question isn't whether Tesla's technology works. Nearly 2,000 unsupervised rides across multiple cities with zero collisions answers that. The question is whether Waymo's architecture can evolve to match Tesla's adaptability fast enough. Because right now, one company is expanding aggressively across dozens of cities while the other just had their entire fleet shut down by a power outage. That's not a temporary setback. That reveals which approach was built for real-world resilience and which was built for controlled demonstrations. So here's the bottom line. The San Francisco blackout didn't just show which robotaxi worked and which one failed. It revealed two fundamentally different approaches to autonomous driving. Waymo built a system optimized for perfect conditions. Tesla built a system designed for real-world chaos. And in actual deployment, chaos wins every time. The numbers prove it. Nearly 2,000 unsupervised rides completed. Zero collisions across 300,000 California miles. Fleet expansion from 28 to 1,655 vehicles in 4 months. April 2026 mass production launch means Cybercabs could be operating in dozens of cities within 16 months. This isn't a test program anymore. This is full-scale commercial deployment happening right now. And here's what makes this even bigger. The same AI that navigates blackouts and unpredictable traffic is the foundation for everything Tesla's building next. Optimus robots, autonomous logistics, future systems that must adapt without constant connectivity. Tesla just proved their approach works when infrastructure fails, and that changes everything about how we think about autonomous technology. Now the real question, what happens when millions of Tesla owners can add their cars to the robotaxi network and earn 70% of ride revenue? When $200 monthly unlimited ride subscriptions become standard? Drop your prediction in the comments below. If you want more deep analysis on Tesla's robotaxi expansion and what's coming next, hit that subscribe button for Tesla Zone. Smash the like button if this breakdown added value. And turn on notifications so you catch our next video covering Cybercab's production timeline and regulatory breakthroughs. This is Tesla Zone. The robo-taxi war just accelerated, and one company is already miles ahead. We'll see you in the next one. Tesla designed the Model 2 to survive 3 feet of floodwater, laugh at 15 years of road salt, and stay solid past 200,000 miles. Battery packs that won't corrode, suspension that absorbs every pothole, screens you can actually read without squinting. But here's the catch. This tank of a car isn't chasing 0 to 60 times or impressing anyone at a stoplight. Tesla killed the performance thrills to build something that just works every single day for decades. So what did you actually lose when durability became more important than speed? Here's the brutal truth nobody talks about. Over 40% of Americans live within 50 miles of coastline or in regions where roads get salted 3 to 5 months every year. That means your $50,000 EV is breathing salt spray, soaking in brine runoff, and sitting in standing water every single winter. Battery packs that cost $9,000 to $12,000 to replace, they're failing not because of degradation, but because water found a way in. Suspension components seize up, wiring corrodes, insurance companies write off the entire car